Hi students, in this session I am going to discuss about the complex numbers. Okay, so up to 10th standard our universal set is the set of real numbers. But in the 10 plus 1 and 10 plus 2 our universal set becomes set of complex numbers. How this word is derived? Let us see one by one. Okay. For that, I would like to give one example here. For example, if we solve the quadratic equation x square plus x plus 1 is equal to 0, then what the roots we are going to get? Let me explain. X is equal to minus b plus or minus root over b square minus 4. A is 1 and c is also 1. Then by 2a. So minus b plus or minus root over b square minus 4ac by 2a. Here a is 1. Okay. Now what we are getting? Minus 1 plus or minus root over 1 minus 4 by 2. This is equal minus 1 plus or minus root over minus 3 by 2. Whenever the negative number occurs in the square root, we are saying it is undefined and we are neglecting such values and we are concluding there is no roots for this equation. But it's a blunder. For every equation, there will be roots. For every equation, there will be solutions. But whenever the negative numbers are occurring, then we are saying roots are not defined. No. Every equation will have the roots, therefore we must and should show the roots. It means we have to define these numbers also. For that, whenever the negative numbers are occurring in the square roots or fourth roots or sixth roots, then the scientist Euler, he invented one number and that is root minus 1 and he denoted it as I. Here I means iota. Okay, so root minus 1 is equal to I is called imaginary number. Okay, that is the reason whenever we are getting root over minus 2, then immediately write it as root minus 1 into 2 and separate them. Write it as root minus 1 and root 2. Then we write it as I root 2. The numbers which are having I are called imaginary numbers. Imaginary numbers. It means from invention of I onwards, we have one more set of numbers and they are named as imaginary numbers. Imaginary numbers always contains the number I. Therefore, shall I write I root 2, I root 3, I root 5, etc. They are known as imaginary numbers. Okay, so today onwards, from this class onwards, whenever the negative number occurs in the square root, we have to take them as imaginary numbers. Okay, so this is the story. Here, most important point is I is equal to root minus 1 and it is named as iota. Okay. And the numbers which are always containing I are called imaginary numbers. Now, the combination of, sometimes we are going to see the combination of imaginary and real numbers. Let me show you here. In the previous problem, here observe, this is the number which is having, both. Here it is real number and it is imaginary. I am writing here. It can be written as now minus 1 plus or minus root over minus 3. Therefore, I root 3 by 2. Now observe this number. It is the combination of real and imaginary numbers. Now, the combination of real and imaginary number is called complex number. Complex number. So complex number means the combination of real and imaginary. It means in the same number you are going to find both real and imaginary numbers. Therefore, this session is nothing but complex numbers. So now I am going to write the title of today's session, complex numbers. That is the reason in the intermediate standard or 10 plus 1 or 10 plus 2 standard, we are going to see the universal set as set of complex numbers. So after knowing what is the complex number, now let me write one order. All of you know the natural numbers, we say they are the countable numbers. What are they? They are denoted by capital N. And all of you know that capital N is a subset of whole numbers. And whole numbers are subset of integers Z or I. Integers are denoted by Z or I. And integers are subset of rational numbers. Rational numbers are subset of real numbers. And real numbers are subset of complex numbers. So this is the order. Natural numbers subset of whole numbers subset of integers subset of rational numbers subset of real numbers, and real numbers are subset of complex numbers. So today onwards, from this session onwards, our universal set becomes set of complex numbers. But actual definition of complex number, let me introduce you. That is, I am taking two numbers a comma b, both are from set of real numbers. How the complex number is defined? Let me explain. Let the two real numbers a comma b, if we write them in the ordered pair a comma b, then this ordered pair is called complex number. This ordered pair is called complex number. Okay, but actually what it means? It means A plus IB. To write, to read, to take A plus IB form in the calculation part, it is somewhat painful and strainful. To avoid that pain and strain, we are representing the complex number as in the ordered pair a comma b, and we are representing the a comma b in the plane, and that plane is called complex plane. On that complex plane, we take real parts on x-axis and imaginary parts on y-axis. That is the reason it is said to be real axis and it is said to be imaginary axis. Since we are assuming real and imaginary axis on this plane is known as complex plane. And this complex number is located on this plane like this. Whatever the point you are locating in the geometry, same as it is. Take x-axis as real axis, y-axis as imaginary axis, and locate a comma b. That is the reason this plane is called complex plane. And first of all, one complex number is represented on the plane by organ. That is the reason this plane is also known as organed plane. And here I would like to say one more important point. That is, in this A is called real part and B is called imaginary part. In general, the complex numbers are denoted by Z. Z1, Z2, Z3, Z4. Therefore, real of Z is equal to A and imaginary part of Z is equal to B. This is the story of complex number, and the set of complex numbers are denoted by capital C. This concept is most useful for the forthcoming chapters also. Okay, now, right.